three-dimensional internet today, and we've all submitted forms and received information back from websites. And three-dimensional internet would have a lot of similarities with today's technology, and it would have differences. Mainly, 3D internet is not only just to display 3D graphics, but it provides a complete virtual environment in the sense that it enables the users to interact with the system and creates the image that the user is a part of the system itself. However, the current internet structure is a two-dimensional structure of pages with links that is used to exchange information, and is considered to be flat and abstract connection of documents. If you consider the 3D internet architecture, as we said, there are some similarities with today's technology. In today's technology, we have World Wide Web, WWW. In 3D counterpart, we have Universe. They both are responsible for domain name systems, which we will get into shortly, which is creating the domains such as .com, .org, and geographical domains such as each individual countries that make up the internet. In terms of two-dimensional internet, we have servers. So in terms of three-dimensional internet, we also have servers, but they are called world servers. And websites in 3D are considered web places to signify the presence of a 3D. So we have similarities and we have differences. In three-dimensional internet, since we are dealing with animations and moving objects, we need to consider large amount of data, and therefore large amounts of data would require different sets of systems. One of these differences is considered in the word servers. Since word servers need to keep large amounts of data, therefore one single server is not going to be enough for transmitting all of the objects' data. We need to have multiple number of them. As far as similarity is concerned, word servers still provide static and dynamic contents of web places, and they coordinate communication between the users via email and messaging, and they provide visual media and three-dimensional contents to the users. But as we said, since there are a large number of data flowing between these servers and the users, we need to have more than one, as is shown in this figure. We have in this figure two different sets of word servers, and we could have more. In addition to the word servers, we also see a server called ID server or avatar, and their function is to control the number of users in the system and to ensure privacy and security of the exchange of the data between the users. The ID avatar server can be combined with the word server, which in that case the users can directly interact with it and with the word server, or it can be a separate identity in which the user would interact with the ID server, and then that interaction would be submitted to the universe, which then would be routing that signal to the appropriate word server. We talked about universe server, this being a analogy to the WWW system that we now have, and they both control the domain name system, which is the directory of users in the internet. It provides the geographical information, as we talked about, the domains of .com, .org, and each individual country is having a subdomain within the internet. The client is still a browser in the 3D internet, but however that browser needs to have 3D rendering capability. So in order to render three-dimensional objects, we need to have a special type of browsers, and one of the softwares that enable the browsers to display these three-dimensional virtual environments is what's called X3D, which is called Extensible 3D, and is a standard for delivering 3D graphics. It was started in year 2000 by Web3D Consortium and was a successor to a software which was called Virtual Reality Modeling Language, VRML. The nice thing about X3D was that it was using a XML language which is called Extensible Markup Language, which is used extensively in the two-dimensional internet today, and it is comparable to HTML language. Therefore, it gained popularity. The capabilities of X3D is that it is capable to render 3D geometry and graphics. It can produce animation and user interactivity, and it does that through software rendering of graphics when the hardware system is not available. Each of the three-dimensional objects is produced by a scene graph. A scene is a collection of all of the three-dimensional contents, which is consisted of the geometry, shapes, appearance, materials, animations, and how they interact with the users. And each of these scenes are described by the XML language, which is the Extensible Markup Language. And I have an example of that at the bottom of the page, which is the scene structure in XML. The scene would be considered as a root element, and that have shape, appearance, and material. So the shape can be considered as geometries, such as cone, sphere, and cylinder. Appearance can be considered as animations, and then material can be considered as color and texture. Within the browser, once the browser receives the scenes, then the parser within the browser would extract all of the scenes from the stream and would transfer that set of data to the Scene Graph Manager. The Scene Graph Manager would then obtain all of the XML coded data and produces the 3D objects. And that 3D objects would then be rendered onto the browser. Within this browser, the user has the ability to interact with the object through script language such as JavaScript, and the user will be able to write animation code such as events that will be able to interact with the object at this interval. A good analogy between three-dimensional and two-dimensional XML coding is shown here. In two-dimensional XML, we have element, and that corresponding three-dimensional terminology is called node, and then the attribute is will be field in the three-dimensional. So example would be the root element player would have element first name with the attribute John, and an element last name with the attribute of Smith. So in 3D, we would have the root node as seen, would have a node shape, which would have a field sphere, and then we'll have a node material, which would have a color that is made of a portion of red, green, blue. So in this case, each of those colors would be 50% would be combined to produce the desired color. So I've shown here in this figure, I have four sets of objects, a sphere, a cone, a cylinder, and a cube. So each of those have a particular shape, materials, and appearance attached to it. And altogether, the four are combined inside one scene. And we're going to see a picture of that very shortly. Here it is. This is a picture of the four objects that made up the scene in the previous example. They all have different colors, as we discussed, and then the shapes were explained by their XML coding. An interesting feature of the three-dimensional objects are that they are all made of triangular mesh. So each object can be considered to be a combination of triangular mesh that are progressively added together to produce the objects. And much more advanced objects can be produced by combining these primitive objects together and producing much more advanced objects. But when you string these objects, you are actually stringing these collection of meshes across the internet. Another interesting point is, if you notice closely the text hello x3D, you notice that even the text has been configured as triangular meshes. So that would be another differences that you can consider between the three-dimensional cases and two-dimensional internet. In another example, the scene consists of a sphere and a text. The text is still a hello world, but then the sphere is starts by having a property or the field of material as a color of blue, but an animation has been added to this sphere to include the map of the entire world, right on the blue sphere. So it creates the image that the blue sphere is actually the planet Earth. So I'll show you a picture of that, and you can see how the animation parts of it is considered. Here it is. So we started off with a blue sphere, and then we added the animation that includes the map of the entire world. So we created an image that we have we are right near the planet Earth here in this case. So I'll show you the three-dimensional browser. So to give you a picture of what the three-dimensional interaction is considered. So if you want to interact with the object in this case, you can vary the positions and interact with the objects. So that clearly shows you the three-dimensional structure of these figures and how you can interact with it. Similarly, with the planet Earth, we can use the three-dimensional objects, and you can have all kinds of variations, and you can take a look at the map of the Earth from different sides, and you can look at every locations of the planet in a three-dimensional system, and view the world from different angles. Okay, I had two references on my project. The first one was a paper that was the title Towards 3D Internet by the authors given, and a website on X3D, which is x3dgraphics.com. So I've given you the full references for my two references that I worked on my project. This concludes the time that I have for my presentation. I thank you for your attention, and if you have any questions, please contact me through my email. Thank you.